Hey everyone, welcome to Manufacturing Live. As you can tell, we're in a little bit different spot today. We're actually at Speedway Motors in Lincoln, Nebraska, and with me I have Dave Wallace. Dave, how are you doing today?
I'm doing good, doing great.
So, before we start and jump into the manufacturing, as you can hear around us, what do you do here?
My title is I'm the Director of Manufacturing at Speedway, so oversee all our manufacturing from metal cutting, fabrication, which entails welding, fiberglass, so anything where we're building all our own parts in-house.
Okay. So this facility here is one of the newer additions, right? Like you guys moved into this one not that long ago, correct?
Yes, we've been building it for about the last 2 years during COVID. Finally got finished up, done to where we moved the fab shop and welding in roughly starting about January, February, mainly February and in March, and then about March, over 6 weeks, we moved in the CNC department over about a 6-week period.
Okay. So lots of changes, lots of cool things. We do have a little bit of footage we'll go throughout when we're talking here a little bit, but please remember, this is live. See, we actually see your questions, so please ask questions. Dave and I are going to talk about what it takes to manufacture parts as one of America's oldest speed shops. So let's talk about some of the products that you guys develop and you guys do in-house.
So being in motorsports, we cover a lot of bases. So street rods, hot rods, muscle car parts, just about anything that races on dirt, a little bit of drag racing. So kind of anything motorsports related. So within that, like street rods and hot rods, we build our own frames. Fiberglass plants, we build like T-bucket bodies out of fiberglass. And we also build a lot of just other component piece parts out of fiberglass, carbon fiber. From there we kind of move into muscle cars where we build entire suspension assemblies. So complete front subframes, rear suspension assemblies, sway bar upgrade kits, kind of you name it. Anything, if there's a demand, we try to get involved and build something.
Okay. So I think I may have dropped my mic. Let's make sure. Can everybody still hear me? Are we good? Perfect. So disaster one out of the way. We broke something and we're still good. The big question I sort of have, and I think this is, me coming from Nebraska, being around here, I have a little bit different perspective, but as you build and design and prototype and R&D and make your own products, what does that look like doing it out here in the Midwest?
So here at Speedway, because we're in motorsports, a lot of our employees are involved in different forms of racing. Kind of anything you can think of in motorsports and racing, we have somebody that's in the business working, is involved. So we get a lot of product ideas from our own employees. We get a lot of product ideas from just customers. Like somebody will have a problem, might reach out to us, or we continually look for things to try and fix something that maybe somebody doesn't realize there's a problem, or we try to just make things better. So
yeah, last time I was down with the R&D group from our side, right? We went over to the R&D shop, and I didn't realize you guys made a smaller version of the 67 through 72 steering wheel. Like it was in the new truck on the project, and if you haven't seen it, go to Speedway Motors, look at their 67 C10 project, because it is awesome. But like just something like that, like we all grew up with the big farm truck steering wheels, and you guys now have one that's smaller for bigger people like me to fit it behind the under the seat these days. So in all of that you do with prototyping and racing and machining, like let's talk a little bit about if you have an idea and you produce it, because there's a lot of machines in here, there's a lot of equipment in here. What's sort of a process look like for you guys to test out an idea and make it reality?
The normal channels are, it'll start out as an idea, goes to the marketing department, gets vetted on basically the cost, how big is the market, what's the volume. Like they look and just make sure we check all our boxes. Is this something, is it a road we want to go down, something we want to make? Does somebody else already make something similar? Can we make it more cost effective? Can we make it better? Can we make it a better quality? We look at a lot of areas, and if it's checks all the boxes, yes, it goes from there. Goes to the engineering department. They'll start the prototype process. From there, then it usually moves from prototypes to basically makes it to doors here. And we start either machining parts, lasering them, bending, welding, fabricating, whatever it is. We go through prototype stages. And at that point, once we test, do everything we want to, then we'll usually move into what we call pre-production of trying to get a certain volume of parts on the shelf. And a lot of times we're staging this out depending on trade shows.
Okay.
So we're trying to either get it into market before a trade show, or some things are basically brought to the public at a trade show.
Okay.
But usually in the background, though, we've already did prototypes, pre-production, testing, all of that's already happened.
Okay.
And if it's for sale at a trade show, the goal is we have a substantial inventory already built up, so when you see it at SEMA, NSRA, PRI, those are kind of three major trade shows for motorsports, it's ready for sale in the catalog or on the website.
Okay. I'm checking here just to make sure we don't have any questions come up. Please ask questions for Dave. I learn so much from him every time I stop and chat with him. I do have a question though, because some of the team flew in from my side yesterday to help with this, and I was saying, one of my biggest memories of Speedway was, gosh, all the way back in like 2002. I got to meet Carson, and back then it was like the goal was, if we have a product on the shelf and you order it, it's going to be there in 4 hours. Really the Amazon of motorsports before Amazon was around. And you were saying like that has continued now to even be faster in how you guys ship. And it was a really interesting thing to see that, like, most of the times people think of consumer products like what goes through Amazon as that's the golden standard, but that's something you guys have done really well for decades now.
Yeah, Carson and the whole entire warehouse team, one of their goals is to get, basically, you order a product and within, I don't remember the amount of minutes, but it's down to minutes now. The things get packaged, get put in boxes, and it's ready to go out the door. And there's a bunch of checks and balances that happen of making sure the products are all in the box. It's everything you ordered, and there's, I don't know how much we want to give away, but it's by weights and volumes that everything gets checked. So there's a lot of automation in the warehouse side to get things boxed, packaged out the door efficiently.
Yeah,
and we're talking like, it's not in the hundreds of orders we put out a day. It's a lot of days we're well into the thousands of orders that get placed a day.
Yeah, we don't want to give out the secrets. We just want everyone to know that you guys have always been innovative in what you do, which sort of leads to a discussion we're going to have here in a little bit. I got a couple part for you. So if we take a look at this part, so this is one of your shock bodies, right? Or pieces of a shock body. Can you talk a little bit about, again, in a general term, how you guys approach taking something as complex as a shock and making it efficiently to be able to meet those deadlines for shipping? Because most companies would take a part like that or pieces like that, and it would be one off, one off, one off, one off, and then if any little hiccup, you can't ship a shock. So I don't know if you want to explain a little bit about, in general terms, how you guys are looking at things different than everybody else?
So we don't have the body, but this is a gland nut, the shaft, and then there'd be a body and then another eye on this end. So yeah, we look at it just from the aspect of, we try to standardize some parts. We can't standardize everything in racing. So this is just one end, it's a billet end. This end here is a forging. We have high precision forgings we do. A lot of pieces start out as billet, which the gland nut here is billet. And then the shafts are items we build also. So a lot of it we try to standardize where we can. Other things we just try to build them in bigger volumes of parts that we have on stock. We're a little bit different to where some things we're kind of doing a little bit of just-in-time manufacturing, but a lot of what we do is we have to have inventory because you need the inventory to turn around and sell the parts. Right. But it's a balancing act of how much inventory, how much money, labor, and materials you have tied up into it versus having inventory on the shelf. So, and here at this location, we service, we have an engine shop here locally in town we build some parts for. We have a shock department here in town we build parts for. We have another location in Boonville, Indiana that we manufacture a lot of parts for. They go there, get assembled, And then from there, there's 2 other locations that branch out that we feed locations we own where we build shocks.
Okay.
And it's not just shocks, so it's shocks, components that go into radiators, engine components are going in the engines. It's, like I said, we're kind of building a little bit of everything under the sun.
Yep.
If you want a car, we can almost build the entire car.
Yeah, which is pretty cool and pretty amazing, right? Like you were talking about yesterday that you're one of a few in the United States that can build radiators, and like there's a specific process you do that. And it seems like as like a hot rodder like myself, one of the coolest things is I break something and I need it, I can just go to one website and find what I need to fix what I broke. Like to me, that's a pretty amazing process to be able to support.
Yes, our website is big, our catalog is big,
Yeah.
there's a ton of parts on there. So yeah, so it's something you don't see in the background is our merchandising, our marketing, the IT department, the web developers. Like there's a whole army of people at Speedway to build, maintain all the areas of basically all the aspects of the business.
Well, it's interesting because one of the things that I've sort of learned over the last few years in doing analytics and talking with companies is a lot of manufacturers are becoming data companies versus manufacturing is the byproduct of the data that they ingest, right? So like what you sort of mentioned there is there's an enormous amount of data that sort of drives what to produce, when to produce it, how to produce it, right? It's not just come in on a Monday morning and we got to make 500 of these. It's more of we need to make 500 because data tells us where that's going to be.
Yes, so we operate like a job shop because we have customers, but all our customers are internal. It's different departments of the business, whether it's the Micah DeWitt's building radiators, or different guys building shocks in different departments, or somebody in the engine shop, or people on the merchandising team in the warehouse where we're sending products straight to. We have 3 main warehouse locations, and then another 4th one that's smaller, but they're all wanting the parts that we make, so we kind of work like a job shop, but everything we do is internal, but it's all driven off the data that comes out of merchandising and or the pre-production prototype parts, stuff like that. So
Okay. Let's see if we got any questions here. Someone said that they need a job in your factory, which will get us to a discussion we're going to have here in a little bit. Let's see what else here. This one, I'll ask you. Engineering department's a little bit adjacent to what you do, but I'll ask this. On which rate the design requirements keep changing in the industry? Do engineers work on design and testing all the time? So basically, do your engineers do design and testing, or are they just design?
No, it's kind of a loaded question. So our engineering department, I guess compared to some businesses, we have a big engineering department. Compared to some, we're small.
Yep.
For us in motorsports, I'd say we're probably a little above average on size. And the engineers in our business, and even here myself and some of the employees in the shop, we are involved in the R&D and the testing. Some of it's destructive, some of it's non-destructive testing of parts, and the engineering department is involved.
Okay.
Usually a lot of departments we stay involved so we know what's going on, or we can add somebody's expertise to help. The engineering department, right over here in these offices, we have all our CNC programming. There's actually engineering and mainly QC. So the engineers will come over. They can work directly on the floor with any of the guys running machines to basically check like the manufacturability of products, or they might engineer it, and then somebody on the floor will want to make a change to make it easier to machine, or maybe make it economical or make it better. So yeah, it's a big active group of people that are all involved with each other. It isn't just engineering saying, here's your model, build this, and then we figure out how to build it, which is kind of the job shop mentality of, here, just build this, here's the drawing, build it to the drawing.
Yep.
There's a lot of back and forth, give and take of, can we build it better? Can we build it to a better quality? So there's a lot of feedback avenues throughout the business.
Well, and it was interesting, outside the door over here, there's actually part of one of their things is you have a voice, right? That's one of the foundation principles of Speedway. And I think like in talking yesterday and working with your team here, and getting to hang out with the engineers over the last couple of years, it's interesting how, because they all race and because you all work together, everyone has a group philosophy of let's make the best product for the end user. At least that's what I pick up.
Yeah, as a company, we have a lot of very smart, intelligent people everywhere. And so if somebody's got an opinion, like we'd rather hear it. As a group, collectively, we're way better than just saying here's one smart guy that came up with a product and we're building it and running with it. No, it's a group effort of engineering, the QC department, the guys on the floor running machines, the guys that program, which we don't have one or two programmers in the CNC shop. There's multiple guys that program. Same thing on the fab side. There's multiple guys that program the lasers. All the welders TIG weld, they all MIG weld, they're all certified. We don't really have one person just stuck in one area. They all overlap and they all put in opinions. We don't try to have a lot of meetings, but we end up having a lot of small meetings on ideas, products, making things better.
Okay. Let's see. There's a question here, again, a little bit more design is, what are the skills required for a mechanical design engineer as a fresher after completing graduation? So what would you recommend to someone that is a mechanical engineer and they want to get into doing something like this?
It'd be more of a question for Jared that runs the engineering department, but I do know we have just some draftsmen. We have some mechanical engineers that have gone to like a local trade show or trade school, so like a 2-year degree on mechanical engineering, and we have other guys that have gone like the full mechanical engineering route. So we kind of have a wide variety of avenues, and we have guys that have never been to school for it, but they have a really good solid foundation of mechanical engineering and how things work, and sometimes they rely heavier on other guys they went to school for mechanical engineering and they know how to do all the math and the design and the engineering. So it's a wide variety of people. It just depends on their skill set. I would say their attitude, like do they want to learn, their knowledge. I mean, I've never been to school for machining. Probably half my employees, welders included, have never been to school, but they've learned on the job.
And they do a phenomenal job too. Which leads me to the question I have for you. You have a lot of employees here that work multiple shifts. How do you build a culture? Because here in Nebraska, it's sub 2% unemployment, right? And like, there's somewhere like 30,000 more jobs than there are people in the state. So we run into an issue of here, how do we find one, a person that's willing to work, but then number two, how do you build a culture to where people want to pull their weight or be part of that? Like, what have you guys done here to be successful?
It's been a long road. So when we started, the shop looked nothing like this 10, 13 years ago. Probably 13 roughly years ago, 10 years ago. We had 2 pieces of CNC equipment and maybe a dozen employees. Okay. And so as we started growing and adding machines and hiring people, we just started then of trying to get the culture to be driven off of we'd hire people, and we did a lot of internal training. Okay. And that was because we had to of hiring people. Okay. So our wages have continually gone up, commensurate with the training and people's skill levels in the machines. So we didn't ever start out with where we had a $350,000 machine with multiple axes and sub spindles and twin turrets. We didn't know how to do that at that time or have the skill set of people. So we grew into it, and at the same time while we're growing into that, we kept adding capabilities that we couldn't do before. In the engineering department, basically, as we would add capabilities, they would always see what we did and learn what we could do, and then they would design something harder. And then we would get good at that, and then they would design something else and raise the bar again. And so it's been a big learning curve. And as we've hired people, we've just tried to do our best to retain them and work hard at retaining employees, or all your smart employees. That's what makes the entire business works, is the employees. It's none of the machines, it's the people. So we just tried to put a culture in place of continuing education and giving them room to grow, and it's not any department, it's any one department.
Yeah.
So.
We it's interesting because we were at break in there just a little bit ago before we got on the air, and like I was sort of watching the group, and like the whole group went in for a break and they were all there talking. It wasn't like some companies you see where there's like a whole bunch of 2-person tables and nobody really interacts. Like, to me, coming from this side, that was a pretty interesting thing to see how everybody just naturally all has a conversation together, which you don't see a lot of today.
Yeah, we try to keep like I said, it started out as a small team of people, and it's growing bigger and bigger, so it gets harder because you have a lot of different personalities, people, ages, but we've always tried to get it to where it's one great big group, team effort of people. We all have the same goals that we're trying to do within our department and a company, and so we've just tried to keep everyone on the same page, same goals, same training, whether it's safety, continuing education, hiring new people. One of the big things is like the voice thing of listening to the employees of what they want to do or what they need to do their job to be successful.
So you bring up a good point, and I want to highlight this because I've worked in fab and machining for a long time, and I have never seen welding areas like what you guys have over here. They are amazing. So can you talk a little bit about like when you got to move over here and lay that out, like what the process works like? Because I remember the first time I was over here, you were talking about how all the welders had input to how their cells could be, right?
So in our old location, we were 27,000 square feet. We weren't crowded at first, but as we started adding machines and more people and more things, it didn't take us long which you'd been in the old building. We had filled it up to the point of like we efficiently used our space as much as we could by stacking machines and putting them next to each other. And our efficiency was going down and down and down because we didn't have floor space or room. And so when we decided to renovate this building, it was 77,000 square feet. We drew a drawing of the building in SOLIDWORKS, so everything was three-dimensional. We made models of the machines, and initially it started out, I laid them out on how I thought I wanted things, and then we took the models, gave it to all the managers, or had it on a shared drive, made it accessible to all the managers of the employees so they could open it up and they could move things around of where they would like things, because they're the guys that are on the floor that are working. And so our welding department in the other area was just kind of there's a welding room with 2 guys, and then it ended up being 3 guys, and it was kind of a hodgepodge of things. So the welding guys really got to decide how they wanted it laid out, what would be efficient for them, how we could make it work for production and make them have a really nice welding environment. So we had a year and a half, 2 years of looking at models. The guys were researching on Facebook, Instagram of what's a really super nice welding shop, what's a state-of-the-art welding shop. And so we just started looking at ideas, going to trade shows, getting into other businesses where we could, and learning, hey, how did you set your welding area up? What'd you like? What didn't you like once you did it, or what would you change?
Yeah.
And just a lot of notes from a lot of guys. And like I said, the welders had a lot of input on because they're the guys doing the work. And so we kind of laid their booths out how they wanted them, and then we started setting the periphery equipment up and laid it out, and then it kind of everything just fell into place.
The ventilation system over there is what blows me away. How you have the big extraction coming from all those booths, like whether they're TIG welding or arc welding or any of that, like you would never know that they're actually burning in weld all day long over there because there's no smoke anywhere.
That was one of the things that all of the welders were pretty unanimous. A couple welders had been at other shops for a long time to where it was production welding, and they'd get done at the end of the day, and you didn't think you were dirty, but you'd wipe your face off, and if you had a white rag, it was black. Or if you blew your nose, it was black. And so at our other shop, our ventilation was pretty good. We would do air quality tests once a year, so we were cognizant of it, and we would do testing for sound, air, all of that, and so we were good. And then within our area, within Lincoln, we were actually really good. We just wanted to make it better because we knew we were going to add more welding bays and more things, so we wanted to be ahead of the curve.
Right.
So we went kind of above and beyond. The CNC guys get more new equipment more often because it's easy to set up a welding station and buy 2 new welders and spend considerably less money. So we wanted to make it a great work environment, also to help with basically retention, recruiting of getting people in.
Yeah, which is key, right? Because
Oh, yeah.
you're all vying for the same group of people or same pool of people and within a driving distance. So how do you stand out but then keep the ones that can help benefit long term, right? Like that sort of comes into that key of it's easy to get an employee in the door, but how do we keep them long term so we don't lose productivity over a 5 or 7 year period?
Yeah, big thing is the employees here, and I have a great group of guys all the way down, and we don't have a lot of management or I'd say overhead here. It's myself, 3 department managers, and then a total of 4 team leads under them, and we have 70 people. So we're
Pretty flat.
Oh yeah, we're really low on management side. It's mainly workers on the floor, and all the team leads work on the floor. Like if it's guys over here, they're programming, they're out working, they're help setting up, they can run machines. If it's in the welding department, the managers and the team leads, they can all program and run the press brakes, they can run the lasers, they can program and run the robotic welder, they can go over and get under a hood and MIG and TIG weld. So yeah, everyone here works on the floor, so we're low on that, but we've always just tried to have really good, high quality group of guys and train from the bottom up, whether it's guys going to school part-time welding and then they come in and weld after school or have a part-time job, or if it's the CNC side where we have a scholarship program where they're going to school at the local tech school, Milford, and then they come and they work part-time at night on the night shift, and we try to get them to where they're working part-time while they're in school, and then we're educating them and training them. So while they're in school, they're elevated and getting more than what just I would say your traditional student is just going to school and has a part-time job at like a Burger King or McDonald's or something. We want to give them an education.
Which is smart, and Milford's near and dear to my heart. So you and I have talked about that quite a bit. You work on the machine tool side. I help with the manufacturing engineering side. So there's lots of good people that come out of those, but having that real world experience is like the next level jump, right? Because it only works if it can be applied to the real world.
Exactly.
There's a few more questions here, so let me find some that aren't for Jared only.
Okay.
Here's a good question from Eric. Eric from Omax. We were talking about him before. What 1 or 2 products are you most proud of for any reason? Complexity of design, machining. What's something that you had part of, 1 or 2 products that you're most proud of that represents what you've done at Speedway?
Well, there's nothing I've ever done here myself. It's always been the welders, other machinists, engineers, so everything's a big team effort, but one of them I would say from engineering, welding, and machining, we did a bell housing project probably going on 10 years ago now that we started with basically a clean sheet of paper. There was a change of a sanctioning body of what they wanted, and so we started the project, and then we had finished parts, finished and then right into production parts within 30 days of building a bell housing from scratch.
That's impressive. That is fast.
Yeah, it started with engineering, designing, drawing, working with us within the same week to 2 week window of how are you going to build it, so that was all going on concurrent. How are you going to build it to know better how they were going to draw, design, and engineer it? And as we're doing that, we were lasering parts, bending them, forming, making samples, and then going right into machining. And we were doing fixtures all at the same time.
You mentioned the laser stuff, and one of the things that has stood out to me is you see the plastic motors and all those, for test fitting stuff.
Oh yeah.
And you guys now have full sheet metal laser cut size replicas, right? And then Jared was over here yesterday. Jared, you snuck out of not being on the camera here, so I'm a little disappointed. But he was talking about now you have one for transmissions, 480Es and that kind of stuff. To me, that's pretty cool that you're not just having another injection or rotomolded case. Like you actually just use the sheet metal framework to solve the same problem.
Yeah, we're able to, a lot of that goes back. Engineering spends a lot of time. You figure out how you, once you unbolt it, like how are you going to package it and ship it to the consumer, because it's, if you're shipping a metal or plastic engine block, it takes up a lot of space and it costs a lot in shipping. So we did a lot of work, or there's a company did a lot of work on trying to figure out how to package it into a smaller package box for shipping, and then the customer gets it. We have laser etched marks on it, how you reassemble it. Test fit, whether it's a small block Chevy, big block Chevy, LS, Coyote motor, Hemi, the different trannies, to have a mock-up motor block to put in your car.
Which is pretty ingenious, because if you just have those sitting on a shelf in your own shop, they take up a lot of space. If you can break them back down, you save a lot of space in your own shop.
Oh yeah.
So just beyond the shipping, like that's a pretty ingenious idea. The so Brad, who's part of our user group network, he asked a good question. This one might be a little bit loaded because you do standing miles and everything else, but what do you think of LS swaps?
So the LF swaps to me are your small block Chevys of 30 to 40 years ago, which there's so many LS motors in trucks, SUVs. I mean, GM stuck them anywhere, which now it's turned into kind of LS swap anything. So I was at an event this weekend and there was a Miata with an LS. There's numerous cars with LSs, but you'll see them in an LS in anything from a school bus, a Miata, old muscle cars, newer muscle cars, which now you're getting to see Coyote swaps. There's a ton of Ford vehicles get LSs, but the Ford guys don't like to see it, so now it's LSs and Fords, Coyote motors in different Fords, LSs in different Mopars, but there's also Hemi ones of the same generation. But the LSs just seem to be, there's a vast network of people, so there's kind of any problem you have, there's a solution for it. And there's multiple solutions.
Yeah, to me it's also, living out in Colorado, like everything LS was super expensive. You want to go buy a junkyard LS, it was expensive. The traditional small block, big block stuff, dirt cheap all day long. And so when I moved back here, I was like, oh, well, I'll just offload some of my Gen 1 stuff, right, or Gen 4. And I got back here, and it's because of all the racing that's done in the Midwest.
Yep.
It's flipped the other way. And I just assumed, being in Colorado forever, that everybody was doing LS stuff. You know, so it's an interesting thing. I think that's a little bit of a loaded question on the LS thing, though, because sometimes a big block is just a big block and it fits. So let's see. What is today's highly scope of area in manufacturing field? So I think what they're asking is, I'll read between the lines here. I think what they're asking is, do you see manufacturing as a high-tech area today from where it was like even when you guys started 15 years ago?
Yes, very much so. A lot of our machines now, and I describe it to some of the guys that are younger, newer, and they don't, we hire them and they're running a machine, but some of them don't have not that they don't have a good grasp, but to understand how much money you have invested in just one machine tool. Yeah. So like the Trump laser and the sheet loader and all that, to replace and buy that looks easy as it's running, but to buy it, the replacement cost right now is probably $1.2 million for just that piece of equipment. Like the different lathes, NZX lathes, I kind of describe that to them as like you're running a Lamborghini or a Ferrari, because the cost of that machine, you're buying a very high-end Lamborghini, or you're buying like a Veyron or something, a Bugatti. Because the price, by the time you get tooling in them, some of the machines are $750,000.
Yeah.
So the high-tech end of it, I would say yes, because the machines are very high-tech nowadays, where they're monitoring their own vibrations and adjusting their own feed rates and the acceleration, deceleration rates. And that's just the machine, not getting into the software side of it, where you're using like SolidWorks, and we use CamWorks and Esprit, your different software programs to program.
Yeah.
If you've seen the stuff in the background to get it to that level, to do it what you want to do, or the databases that are built to solve the problem for you, they're very high tech. And that's not even getting into the tooling to do the jobs, where you're talking into the different coatings for inserts, geometries on end mills or insertable end mills.
Yeah.
Because we're in the field, yes, the field is very, very high tech. It's just some people don't see it or grasp it as enough. If you're not in it, it's easy to go, you're just using a drill bit or an end mill, or you're cutting something. But I would say the tech schools, different publications, even Instagram, Facebook, showing what people do nowadays. If you're involved, you know a lot of the technical side, how in-depth it is, and how to stay abreast of new technologies of what's out there is always changing.
Yeah, it seems like it's how
a lot.
fast everything's happening, right? And you mentioned, I don't think we talked about it too much in depth, but like a lot of the things you do on your mills, and now you have Swiss and you have some of those, like you're getting to a lot of multitasking things because you want a finished part to come off the machine versus going through multiple steps, which is traditionally you take a part and you put it on a mill and then you put it on a lathe and then you go over here, and like you guys have transitioned a little bit more into adopting that high tech to where raw material goes in, finished part comes off, right?
Yes. We've always tried to do that just because as a growing shop, we've never had as much manpower as we've wanted, or we're growing faster than we can have people. So we've always tried to do multitasking machines, or we've always tried to look at our lathes with bar feeders. If it's a square part and it fits in the round envelope and we can run it through the bar feeder, the mill doesn't know that it's a lathe and the lathe don't know it's a mill, especially the lathes. If we can run mill parts through them, it doesn't know what it's doing. Yeah. So we've always tried to do that. And the employees have always did a good job of trying to multitask or get machines to do things, and then they can go do another task. Yeah, the employees are the smartest part of the equation. And if we can get them off doing something else and they got the machine set up and running by itself, that's great. Which you've seen a lot of different areas where employees were showing you like, hey, look at this. I don't do anything when it comes off. It's deburred, it's finished, it's ready, part's ready to go. Whether it's a seal head like this part that's coming off finished deburred, or like you had noticed we were doing a lowering block, but it's fully deburred when it comes off the machine.
Yeah, that lowering block on the horizontal was pretty sweet.
It's simple part, sawed material, but it's a finished part coming off.
Yeah. There's lots of good questions coming in here. So this one is sort of a future question for you. So what manufacturing processes does Speedway currently not do that you'd love to add?
Probably 3D printing parts out of metal, which is a company, we use a lot of DMG Mori machines, but they've always been on the forefront of metal printed parts, or their LaserTech branded machines, which are primarily, I would say, aerospace, high-end, low-volume stuffs, but they're starting to get now to where that's moving up into more higher production volumes. So that's an area we're not in currently. We 3D print parts, but not out of metal, which we've discussed it, we've talked about it, because we could basically make our own punches and dies for the press brake for making custom tooling. So 3D printed parts would probably be an area.
Okay, it's a good thing you clarified, because everybody that watches and sells a 3D printer probably getting ready to call you right now. So good job on qualifying what type of printing you want to do. Let's see what else we have here. There's lots of good questions in here. I'm trying to make sure that we ask not just the CAD ones here. So one question is, which softwares are preferred for designing parts? I think you sort of mentioned SolidWorks in there. Is speed modeling preferred, or can engineering take as much time as they want to express their creativity?
I think the engineering department, sometimes it depends on how fast we're trying to get something to market.
Yep.
So we might start out with an idea and we really want to get it to market. So I don't know their timelines. I'm involved in it because we're trying to make sure as they're engineering something, they're usually working with us or asking questions about, hey, can you manufacture this, or can we easily build it? But I would say that goes back to where our engineering department, they have an engineering department at the main campus, but they also have a desk. The engineers come out and they spend time out here. They're encouraged to come out, walk out on the floor and see how we build things and see how we do things. And there's some of the engineers might not have been around for a month or a while, or we buy a new machine and they come over because they want to see all the capabilities. And it just, like I said, they might not have known a capability that we had, and they learn of something new, and then they go back and they re-engineer something, or they draw something, or it changes.
It probably depends upon the product line too, right? Because if you're talking the suspension components, because Jared showed me that picture of that Nova that you guys brought in, and like you brought in a stock one and did the road course, and the wheels up off the ground in the picture that he showed, and then as you guys designed the suspension system for that, that's a little bit longer process than like, you know, a simple crate motor sheet metal skeleton, right?
Yeah, so like they'll get a car in, laser scan the entire bottom of the car, and once they have the scan data, then they'll start engineering and working on the suspension design, whether it's, because we've gone through some iterations of truck arms, torque arms, some of them are like a 3-link hybrid of that. So yeah, that's a longer process, and we usually design the suspension, put it on something, take it out and test it and see how it works, and then there's usually changes, revisions, prototypes of what it is.
And you guys have race car drivers around here to do some of that testing too, right? Because you guys go to the good guys stuff and you race the autocross and all that, so like you have professional drivers around here as well. Right?
Yes, so we call it the R&D department, Area 51. And we didn't just pick Area 51, it's actually door 51 going into it, so it's just ironically ended up being Area 51. But yes, Robbie and Al Unser from the Unser family, they spend a lot of time driving vehicles and testing them for us and getting feedback on what they are. So I would say we definitely have a leg up in some areas, at least of the name of what we're doing and the quality of what we're doing, because those guys they're pretty particular on giving feedback if they like something or don't like it. And then from there, yes, there's autocross, road courses, open road races, standing miles. We try to test the cars, the motors in a lot of areas.
So you do standing mile. For people that don't know what that is, can you explain a little bit about what standing mile racing is? So
standing mile is usually on, it's transformed over the last few years a lot. So closed airports, some that I do are closed public streets or highways. Okay. So it's a dead stop, it's not a prep surface, and then you're not doing it by time, you're doing it trying to set a certain mile an hour, whether you're in a half-mile class or a full standing mile. So by standing, it means you're standing start, no prep surface, and then how fast can you accelerate in a mile up to your top mile an hour. Okay. Which it sounds easier than done, but it's as you start getting higher, you have a lot of engineering things going against you between the wind and horsepower and drag of trying to get, usually like a goal is 200 mile an hour, which is,
that's moving.
It's moving, but it's hard. 2 mile an hour is a lot. It takes a lot of horsepower to gain 2 mile an hour, or a lot of less wind drag. So yeah, I do standing miles, open road races. I like those a little bit better. Okay. I did autocross. I'm just not as good as I'd like to be. I like the faster, higher speed, a little more dangerous things. Yeah.
I don't have the reaction time for autocross stuff. It seems like I'm always slow. At reacting for where I want to be. It's probably because I don't do it enough, but I prefer the longer straight stuff. I always thought Bonneville would be cool, but you know, I'm getting a little.
We have a couple cars that we want to take to Bonneville. Speedway's had a history of cars at Bonneville. It was actually our first plant manager. He always took cars to Bonneville and had like numerous records there. I think they might still have 1 or 2 records that are in the 300 and some mile an hour range where they built cars. And a lot of the engineering was done here at Speedway to build the cars.
And you mentioned Bonneville, or you're talking about Bonneville, but you guys are also well known for Pikes Peak, right? That was
Oh, yeah.
something you guys did for years and years and years. And
Yeah, Robbie Unser drove cars for Speedway at Pikes Peak. Same thing goes back. Carson, one of the owners, is a mechanical engineer. He designed, drew, did all the engineering on the Pikes Peak cars. Yeah, so they did Pikes Peak, IndyCar, autocross, sprint cars. Yeah, Speedway's always had a history of having race cars, being involved in them, all the way back to when Bill started the company in 1952. So it's not a buy-sell company. It's always been build things, race them, and win. Try to do good.
Which, if you want to come see some of those cars, there's a pretty cool museum that you guys have down the street too, the Museum of Speed, right?
Yep.
So if you ever want to come to Nebraska, besides, you know, what most people would come to Nebraska for, you have to come check out the Speedway Museum because it is amazing. And like some of the Bonneville cars and a lot of that engineering that was done here in-house, you can see on display over there.
Yes, the museum covers a little bit of everything. So sprint cars, Bonneville, drag racing, Pikes Peak, NASCAR, Indy cars, kind of you name it. But it's also, it's not just racing as you've seen through the museum. It's show cars, so like Riddler award-winning cars. They're trying to cover basically anything that did with automobile history from the turn of the century, internal combustion engines on up to modern.
You know, it's interesting because Netflix just had the Hedy Lamarr story.
Oh yeah.
And her Cadillac's sitting at the museum, which is pretty amazing.
Her original Cadillac.
Yeah, the original one, which the first time I saw it on Netflix, I was like, holy cow, I've seen the car. It's right down here.
Yeah, which a lot of people don't realize. I think Hedy was like a self-taught engineer during World War II and solved, it had something to do with, I'm probably going to get it wrong, but I want to say I think it was torpedoes, the guidance system.
Yeah.
She was actually a model, actress, and then engineer. Yeah.
And she had something to do with either Wi-Fi or Bluetooth or something like that too, like some of the signals we use today to...
She continued on after World War II in the engineering,
I probably got that wrong also, but there's pieces of technology that you can watch us with today that she helped with. So there is a question here, and this one's going to be pretty cool. What's the most unusual or rarest engine that you've developed parts or accessories for?
Oh, that'd be a hard one to answer because we've built a lot of pieces for the museum when they bring displays in and did stuff. So we've built one-off pieces for engines in the museum, but we've also helped, like in the engine shop, sometimes they've came over and we've built one-off parts for people that are racing.
Yeah.
So.
Well, and in the museum, that's one of the rarest engine collections in the world, right?
I think we have the largest engine collection in the world, yeah. I know internal combustion motors. I
know there's stuff over there that I have never seen anywhere else on the planet, so I'm probably a little biased as to how cool it is, but let's see. How would mentally strong while facing difficulties in your day-to-day work? I think that one is, how do you mentally handle the difficulties in everyday work because of, you know, there's things that change, there's things that come up, there's quality requests. Like, how do you compartmentalize the stress of quality, production, teams, meeting, all of that?
I don't know that I put it in compartments myself per se. I usually get out of bed in the morning and I have a mental list of things I want to try and accomplish. And then I look at my phone because essentially my day some days is driven by meetings.
Yep.
And I stick a lot of meetings in my phone personally, of meetings other people request, like SolidWorks meetings we had for this, and then meetings of maybe meeting with the guys to go over something to do with machining or fabrication, or lately it's been contractors on the building.
Yep.
I don't know, I kind of work good when it's, I would say, under pressure or a high workload of things. Yep. If I don't have anything to do, I do have lists of things I want to get done that I fall back on, but it's usually my days are never clear, and if they were clear, I'd be like, I have no work to do today, that's odd. So no, I like having a very full schedule, or meeting with other departments, people, things, solving problems. I really love my job, so I don't go to work with the mentality of, oh man, what do I have to do, or I have to do this today. This is all motorsports, so we don't build anything that anyone needs. So Carson likes to describe it as my job, or our job as a collective here at Speedway, is like going to Disneyland if you're in motorsports.
Yep.
So yeah, so I'm encouraged to go to work every day. Like there's new things we get to work on, new projects, fun things.
Yeah, which is very apparent because everybody you talk to at Speedway, they all have that passion of loving what they do, which is very unique, and it stands out instantly when you hang out there. I can tell you, having the parts store open down here is not good for my bank account now that I moved back, because I come down here all the time and buy stuff. But from the people servicing you at the counter to the people in the shop, everybody here, you can tell, absolutely loves what they do, which is unique in the world we live in today.
Speedway's a big company. I think we're probably over 600 employees, but we work really hard all the way from Clay, Carson, Craig, the owners, on down, of keeping it a family, fun, enjoyable business.
Yeah. It looks like, I'm gonna see if we got one more question. We're coming up on our hour already, which is sort of a bummer because it seems like we've been talking for about 10 minutes. Let me see if there's any here. I think we got most of them answered. Eric did reply, frequency hopping is Hedy Lamar's contribution to science, and she was a co-developer of a system to improve reliability of Navy torpedoes. So
we're partially correct.
Yeah. So thank you, Eric. We can always count on Eric to chime in and help us be successful. So with that, if somebody wants to learn more about Speedway, relocate here and come work with the team, what's the best way for them to get a hold of somebody or share their information?
On our website, we have a careers tab.
Okay.
So you can go to the career tab, and that lists all the different job openings that Speedway has. But it's also, there's a contact to get a hold of, like an email that goes to we call our people's op department to go there. We always encourage, even if we don't have a job application open for something, we're interested in somebody sending their resume in, because we might fill a position for a qualified person. Like you said, unemployment's below 2% here in Lincoln, so we're always trying to look and find good qualified people. That's what's made the business run.
Yeah.
The people.
That's how you survive long term, right?
Yep.
So with that, Dave, I can't thank you enough. Everyone watching, thank you for joining in our first live in a shop with Manufacturing Live. We're looking to hopefully do these once a quarter, so please tune in, like, subscribe, join the list, add more comments. We can't wait to hear from you, and thank you guys again for joining us today.
Yeah, thank you.